Hello students, I am explaining chapter number 1, Matter in our surrounding, class 9 science. And the solid state and the liquid state already I have completed, and in this video I am going to start with the gaseous state. So let's start with the gaseous state. As we all know, matter is divided into three states, that is solid, liquid, and the third one is gaseous state. So these two, solid and liquid, already completed and I have uploaded the video. Now we are going to move with the gaseous state. So let's start. So this we are going to study with the help of one activity, which is the activity 1.11. So these all notes are from NCERT book itself. Just little bit I have explained all the notes to understand or to make it easy for you all. So the aim of the activity is to compare the compressibility of solid, liquids and gases. So we are going to see the compressibility property in case of solid, liquid and gases. Material required 300 ml syringe. So we require 3 syringe. The capacity is 100 ml. Then we require rubber cork, water, piece of chalks and Vaseline. So you can see here, this is syringe number 1, this is syringe number 2, and this is syringe number 3. So I have taken 3 syringe here, and with these all we also require rubber cork, water, piece of a chalk powder and Vaseline. So remember these all. Now, procedure. Take 3 empty syringes and close their nozzles tightly using rubber cork. So what we are going to do, we are going to take 3 syringes, that is 1, 2, 3, and we are going to close their nozzle tightly by using rubber cork. So these are the nozzles you can see here. So these all the nozzles we are going to tightly pack with the rubber cork. So imagine now I have packed the rubber cork for all 3 syringes. Now the next step, remove the piston from all 3 syringes. So where is the piston? You can see here, this is called as piston, which we are going to press it and which will go inside this syringe. That is called piston. So we are going to remove this piston. So remove the piston from first syringe, remove the piston from the second syringe and remove this piston from the third syringe. Then what will remain? Only this much of part of every syringe will remain. Now the third step, leave the syringe empty. Sorry, leave the first syringe empty. So in the first syringe, we are not going to add anything. This portion which you can see here, this portion we are going to leave it as it is. So when you leave it as it is, the air will enter inside this portion. So this whole portion will get filled by air. So I'll write it here, air. This is in case of first syringe. Now fill the second syringe with water. So in the second syringe here, we are going to fill this with water. So imagine this whole portion I have filled with water. Let me change the color. So I'll take blue color. So this is fully filled with water. So understand what I am saying. In the first syringe, what we have done? We have not added anything inside the syringe. It is just empty. And because of this, air will enter inside this portion. In the second syringe, we are going to put water. So this whole portion is filled with the water. Now, fill the third syringe with chalk pieces, that is solid. So in this third syringe, whatever portion you can see here with the flower bracket, this whole portion we are going to fill this with the chalk powder. So I am filling this with the chalk powder. See here. So I'll write here chalk powder. And what about this? This is water. So I'll write all here. So try to understand the step what we have done. What we did, we took 3 syringes, syringe number 1, 2 and 3. Then we have removed the piston from all 3. So remove this piston. See this piston we have removed. Now first syringe we have to keep it empty as it is. So when you keep it empty, air from the atmosphere will enter inside this portion and therefore this whole portion will be filled by air. In the second syringe, we are going to fill with water. So fill this whole syringe with the water. In the third syringe, we are going to fill with chalk powder. So see, this air is nothing but a gas. Water is nothing but, here it is liquid. And chalk powder, it is nothing but what? It is solid. Now the next step. Insert the pistons back into all 3 syringes. Apply Vaseline for smooth movement. So now whatever piston we had removed, we have to insert it in all 3. So insert the piston in the first syringe, insert the piston in the second syringe, insert the piston in the third syringe. And whenever you insert this piston, if you want, you can apply Vaseline so that while pressing the piston, it will give a smooth movement. Now push the piston in each syringe and observe what happens. So once you put this piston, from here you have to press the piston in the first syringe, press the piston in the second syringe and press the piston in the third syringe. And now you have to observe what will happen. Now we will see the observation. Now the observation is, what about in case of first syringe? So see here, first syringe, there is air. So let me write it once again. This is the portion, hole filled with air. So everywhere there is air here. We have not added anything in this. So in this case, when you push this piston can be pushed very easily and the air will get compressed. And remember, here there is a rubber cork for all three syringes. It is not opened, it is closed, it is packed. And now when you push this piston in case of first syringe which is having air, the piston will move or pushed very easily. Why? Because all the air molecule will get compressed. Whatever air molecules had filled this whole piston, all these molecules will come down, all will get compressed. And this procedure will be very easy. This process will be very easy in case of first syringe. Now what about the second syringe? In second syringe, what we have? We have here water. Remember, don't forget, this whole portion is filled with water and there is a rubber cork at the bottom. Now we are going to press this piston. See what happens now? Second syringe, which is having water, water is nothing but liquid state. Piston can be pushed very little. Water is slightly compressible. So when you press this piston in case of second syringe, it will not get completely pushed down. Little bit. Now here there is a piston. It may move till here, like this here. So this is the portion or this is the distance which has been moved with the help of this piston. So what this observation shows? It shows that water is slightly compressed. Air we have compressed a lot. Air has got completely compressed, but water we have compressed very slightly. And what about the third syringe? In third syringe, here we have chalk powder. Remember, we have chalk powder or chalk pieces, and this is nothing but what? It is solid in state. Now, when you push this piston in case of third syringe, what will happen? Piston cannot be pushed. When you give the force on this piston will remain till here itself. It will not at all get pushed in the syringe. What is the conclusion based on this all the observations? We can say that gases are highly compressible because when you push the piston in case of first syringe, it will go down. The piston will completely go down and the air will get completely compressed. So we can say that gases are highly compressed. Liquids are slightly compressed. So in case of second one, when you push with the help of this piston, that piston will go little bit down. It will not go completely down, it will go little bit down. Means what? Water can be compressed in a little way. So you can say that liquids are slightly compressed. We can slightly compress the liquid. But in case of third syringe, when you take chalk powder and when you push this piston will not at all move. It will remain there itself. The level of the piston will not at all change. Means you cannot compress solid. So therefore solid are almost incompressible. Incompressible means cannot compress. So what are the reason for this? In gases, particles have large space between them. So in case of gases, particles have large space between them. You can see if these red dots, red circles are the particles. In case of gases, they have much space between them. And therefore, when you compress these gases, all particles will try to come close to each other and therefore gases can be compressed. But in case of liquid particles have less space. So compared to gases, liquid arrangement of liquid particles can be shown like this. So see the space in the particle. Compared to gases, there is less space. And now when you push these water molecules, liquids, what will happen? Particle will try to come close, but they will move very little. They will travel a very small distance. They can compress by very little. Therefore, water or liquid are slightly compressed. But in case of solid, if you see, all the particles are tightly packed, closely packed. There is no space at all. Intermolecular space is not at all there. Now, if you try to compress this solid, particles don't have space to move inside. And therefore, in solid, particles are tightly packed with no space. And that's why solids are incompressible. So this is the reason why we can see this observation in case of this activity. So I hope you understood the activity. Now we'll move with the next. Now the same property, whatever I had explained, we have going to see with the help of NCRT book diagrams. So see here, properties of gases. Gases are highly compressible, so they can be stored in cylinders. So you can see this is the diagram for gases. So this black are the particles and in between these particles they have much space. And that's why gases can be easily compressed or highly compressible. And because of this reason only, or because of this property only, we can store these gases in the cylinders like LPG gas, liquid petroleum gas, CNG gas, compressed nitrogen gas, and oxygen. So in case of LPG, you maybe have seen LPG gas we will get in cylinder. So gas is compressed and then it will be filled in the cylinders. And that those all cylinders we are using for cooking purpose. So liquid petroleum gas means what? When you press the gas, see here, when you press the gas, these all gas molecule come close and they will convert into liquid. And this liquid will be present in the cylinders. It will be in the compressed form. So when you on the cylinder and gas comes out into the stove, here because of the removal of pressure, this liquid will again becomes gas, because you're removing the pressure, you're releasing the pressure, and this gas is burned and the food can be cooked. So that is the main reason why we are keeping these gases into the cylinders. Because of compressibility, large volume of gases can be stored in a small spaces. So you can see here, because of this compressibility property, we can compress the large volume of gases and we can store in a small spaces like LPG. Gases diffuse very fast. Gases diffuse very fast means they can move from one place to another place, or I can say from higher concentration to lower concentration very easily. For example, if this is the room and if you burnt a essence stick here at this corner, and that essence stick if you burnt here, the gases or the smell which is coming from this essence stick, these all the particles of this essence stick will get easily mixed in the air, because the concentration of these all the essence stick particle is more here and less here at this corner. Therefore, from higher concentration to lower concentration, this particle will move faster. And that's why if you stand here at this corner also, then also you can easily smell the essence stick present at this corner. So that is nothing but gases diffuse very fast. Example, the smell of a food spreads quickly from kitchen through the air. Very common example you maybe have seen your home. The food will be cooking in your kitchen, your mother will be cooking food in your kitchen, but still you can get the smell in the hall. Why? Because the particles of that food will mix into the air, and from the air they will easily or quickly spread all over the house, and that's why that is the reason gases diffuse very fast. Now this fast diffusion is due to, the reason is high speed of gas particles, large space between the particles. Gas particles move randomly in all the directions, and gas pressure is caused by particles hitting the wall of the container. So because these gas particles move everywhere randomly, they will hit the wall of the container, or they will hit the wall of the room in which they are present. So these are the properties. So I hope you will understand these all the activities, and you will understand the properties of gaseous state. So here I have completed three states of matter, that is solid, liquid and gases. After this we are going to move with the change in the state of matter. So if you like my videos, share my videos with your friends, and please consider subscribing my channel if you are getting little bit also help from these all the videos. Thank you so much.